Section 3.3 is about the addition rule and how it is used to calculate some probabilities. So what we want to be able to do in this lesson is determine first whether or not two events are mutually exclusive. Another name for mutually exclusive is disjoint. And then we want to be able to use the addition rule to find the probability of two events. So when events are mutually exclusive, it means that they have no outcomes that they share. The two events cannot both occur at the same time. And so if you look at these two Venn diagrams, the Venn diagram on the left shows that events A and B do not come in contact or intersect one another, whereas event A and B on the right do come in contact, and they share some outcomes here in this section right here known as the intersection. So we say that the events on the left are mutually exclusive, whereas the events on the right are not. So say you're going to roll a die, and you define event A to be that you roll a 3, and you define event B to be that you roll a 4. Well, you can't roll a die once and have the outcome be both a 3 and a 4. Therefore, those events are mutually exclusive. Say we define event A to be that you select a student randomly, and that student is a male. And event B, you select a student randomly, and that student is a nursing major. Well, because a student can be both a male and a nursing major, these events are not mutually exclusive because a person selected can fit in both events. Now, when events are mutually exclusive, we can find the probability of event A or event B occurring by merely adding their probabilities together. But when events are not mutually exclusive, then when you add their probabilities together, the events or the outcomes that are in A that are also in B have been counted twice. So what we have to do when they are not mutually exclusive is we have to subtract what was counted twice, and that would be those outcomes that are in the intersection. Let's demonstrate. Let's say I'm going to select a card from a standard deck, and I want to find the probability that the card is a 4 or an ace. Well, if the events are mutually exclusive, then I can just add the likelihood of getting a 4 to the likelihood of getting an ace. Well, you can't pick a single card and have it be both a 4 and an ace. Therefore, these events are mutually exclusive, and therefore I can just add their probabilities without worrying about subtracting the intersection because there's nothing in the intersection. So because there are 4 4s in a deck, then that's 4 out of 52, and 4 aces in a deck, and that's 4 out of 52, then the probability that I pick a 4 or an ace is just the sum of those probabilities. Now you might be thinking, but wait a minute, I picked a card, I picked a 4 and didn't put it back. Now I've got only 51 cards. Well, that's a different scenario. That's what we were talking about last week. We aren't picking one card and then another. We're picking only one card and trying to determine what the likelihood is that that card is either a 4 or an ace. So it's only one card, so both probabilities are out of 52.